All right, I want us to all be perfect with a problem like this. So very, very good. We're going to be very good at this thing. So it gives us an equation, show that the derivative is equal to that. So just do an implicit differentiation there. Remember, if you take the normal derivatives, tag on the y primes. Let me zoom in a little bit better on these things here. So I just did easy derivatives. Just when I took the derivative y's, tagged on the y prime. Took the derivative y's, tagged on the y prime. The derivative y is y prime, easy derivative, and then factor out a y prime, move the x's over, divide by the parentheses. And then I feel good about this because it said show that the derivative is equal to that. And I got my derivative is equal to that. So we're happy. All right, so then it gives us a point, and it gives us an x-coordinate of 1.6, and we're supposed to use the tangent line to the curve to approximate the y-coordinate. So you're going to find the equation of the tangent line, plug in 1.6. That's what we're going to do. So if you have the point, you know how to get the slope of the tangent line is you're going to plug it into this derivative. So plug in the 2 for the x, plug in the -1 for the y, and you're going to get the slope of the tangent line is -1/4. Do your point slope form. You got the equation of the tangent line. Usually if I'm plugging something in right there, I'll get the y by itself. So I move that 1 over. There's the equation of my tangent line. And we're just going to plug in that 1.6. So I did the arithmetic right there. I said that was -0.4, which is like 4/10, -4/10. So then those canceled out right there. And then I just did some like 1/10 minus 10 over 10 to get -9/10. So that's the exact answer right there. If the arithmetic gets a little crazy, they did have on the rubric that they would accept this answer or an equivalent answer right there. All right. So you could have either answer there, just be a little bit careful with your arithmetic there. If it ever gets a little bit too tough, if you're not sure if you can do it, just leave that alone and you'll be good. All right. But we know how to approach that problem there. Equation of the tangent line. All right. Letter C says the point of the curve, the line tangent to the curve is vertical. So you know the slope of a vertical line is undefined. So if the slope is undefined, that means the derivative is undefined. So I saw a vertical tangent line. That means the derivative is undefined. And if this is our derivative, a fraction is undefined where the denominator is equal to 0. So that's like what they need to see first is you took the denominator of your derivative and set that equal to 0. And then you got to remember how to factor that. So practice that, do your factoring, and you get a couple answers for that. But the beginning of the problem said x is greater than 0 and y is greater than 0, that this point exists. So because they said that x and y were positive, that's why I didn't choose the negative answer right there. So we just get y is equal to 1. Horizontal tangent line, take the top of the derivative, set it equal to 0. Vertical tangent line, take the bottom of the derivative, set that equal to 0. All right, and then the last part, you start seeing the dxdt's, the dydt's, and it gives us this equation. It's just a pretty level 1 related rate problem right there. Just if you're taking derivative x's, tag on the dxdt. If you're taking derivative y's, tag on the dydt. If you see that you're multiplying two things together there, use a product rule. And then so they gave us a point in the dxdt, and we're going to find the dydt. So they gave us that. I just kind of wrote that for myself right here. So I have my function. I have all of my givens. Product rule. First times the derivative of the second, the derivative of y with respect to time, dydt. And then plus the second function, which is the y, times it by the derivative of the first. The derivative of 2x is 2, but since I did the derivative of x's with respect to time, tag on the dx dt. And then derivative ln of y is 1 over y, but since I'm taking the derivative of y with respect to time, tag on the dy dt, and the derivative of that is equal to 0. So that's a big thing right there that'll get you points. Taking the derivative correctly, remembering your dxdt's and your dydt's there, recognizing your product rules. Really important that you get that derivative correctly. That's worth points on the AP test. And then after we take the derivative, you can just take the 4, plug it in for all the x's, take the 1, plug it in for the y's, take the 3, plug it in for the dx/dt. So all I did was just plug in numbers right away, and then I combined like terms. I had 8 dydt plus another 1 dydt, so that became 9 dydt, moved that 6 over, and got the -2/3 for that answer. Boom. Cluster